Hello, what's up, Advanced Chemistry, day 8. We are here. It's exciting stuff. After this, 2 more mandatory days left. And you're done. So congratulations, you're almost there. Alright, so day 8 and 9 and 10. We're going to be dealing with reaction rates. So basically, how quickly or slowly chemical reactions take place. And also how chemical reactions take place. So first semester, we talked a lot about bonding and reactions in general. So basically how atoms and molecules bond together and how they split up to create reactions. Okay? But for now, we're going to focus on how quickly or slowly these things take place and what actually has to happen for these reactions to occur. So for today, I want to focus on how these things take place. There are actually 3 things that all atoms/molecules have to do in order to react. In order to talk about that, I want to bring up my popcorn maker and Legos. Okay, I love Legos. I think Legos are really cool. When I was a kid, I was a huge Lego maniac. And then I stopped for a while, I think when I got to high school, and then when I got to college, I was out of the Lego scene for years. And then about 4 years ago, I got back into it. They're actually really fun. And so I missed all these years of the Harry Potter Legos and the Lord of the Ring Legos. And so I'm back into it, and I actually have my own little Lego me. It's pretty fun. So my torso is gone from my body. There we go. Exciting. So the question is, now I know this seems like a stupid question, but it's really all that atoms and molecules need to do in order to connect. So for my little Lego guy here, it's got my name on it and everything. 3 things need to happen in order for my torso, or my torso and my legs to get back together. Okay, think about it. What are 3 things that need to happen in order for these 2 to connect? I know it seems easy, but there are actually 3 things that need to happen. Keep it as simple as possible. Alright, 3 things. Number 1, they need to collide. Okay, it seems as simple as that, but they need to collide. You can't just they have to actually collide. So number 1, they have to collide. Not enough. They have to collide in the correct way. You can't just no. Orientation, that's our word. So they have to collide in the correct orientation, which is that. One more thing. So collide, orientation, and I have to give them something. I have to give them enough energy in order for them to collide. That won't ever break apart. In order for me to take them apart now, I have to do a similar thing. Got to give them enough energy, and they will just eventually break apart. But collision, orientation, energy. 3 things needed to get my little Lego guy back to normal. Alright, atoms and molecules are the exact same thing. There's nothing different. In order for them to react, they don't just have to collide, but they have to collide with the correct orientation. And then they need to have enough energy in order for them to actually bond and react/connect. There we go. 3 things. I also like to bring up anything else really that needs to connect. My popcorn maker. In order for me to make popcorn, I need to set this this little part, the actual part that spins the popcorn around, on the tray or on its base correctly. I can't just put it on in any way. It needs to be oriented correctly, and then it's good to go. If I just let it sit like this, it won't connect because it's not going to move. It needs to plug in. So here we go. There we go. We're good. So same thing with Legos. Okay. So in order for things to react, 3 things have to happen: collision, orientation, proper orientation, and enough energy. Now, in order for things to react quickly or slowly, there are actually more variables that come into play. Today, that's what part of your reading will be on sugar and sugar explosions and things like that. Our next video, or next day, day 9, will be basically a lab simulation that I did at home for you to basically look at. So for reactions to occur, the quickness, or basically how quickly or slowly they occur, is based on a few factors. So to make this more easily understandable, I like to bring up Easter egg hunts. As a kid, I loved Easter egg hunts. I'm sure when I was really young, they were easy, but when I got older, my older cousins would probably put the eggs in spiked bushes or maybe up in the gutters or something. Hey, you gotta, do what you gotta do to get those sweet prizes in those little eggs, little quarters or chocolate kisses, whatever it is. So let's say that it's Easter and your parents are having you go on an Easter egg hunt, and they're timing you. So every year they are timing you to see how quickly or how slowly you pick up the Easter eggs. So let's say it's you, and let's say you have 4 other siblings. So all 4 of you, 4 plus 1 is 5. All 5 of you hunt for the Easter eggs. Let's say there's 50 Easter eggs and you're at some big house, all right, with a big yard. So the rate at how quickly you collect the eggs is what your parents are timing. So the timing, how long it takes you to collect 50 eggs. Now there's 3 things I want to focus on. Actually, there's a 4th one at the end, which is kind of like a cheat, kind of like a cheat code, but that'll be the last one. So the first one is concentration. So how many people are going around trying to get the eggs? Now imagine just you are collecting the 50 eggs. All right, think about, come up with the time, how long it would take you to collect 50 Easter eggs just by yourself. Again, nobody tells you where they are. You're just trying to find them yourself. Let's say I'm gonna come up with 15 minutes, whatever. Now let's say you and all your other siblings go out and try to get them at the same time. How long would it take for all 5 of you combined to collect all the eggs? It would take a much shorter time. The rate increases because more people, you and 4 others, more people are looking for the eggs. All right, it's just how it works. Similarly, in a chemical reaction, when there are more substances, when there's a higher concentration of reagents, the rate of reaction increases. It's just what happens. There's more things there to bump into each other, to collide. That's number 1, concentration. Increasing concentration increases the rate. Now let's say it's just back to you. Okay? Let's say that your parents are timing you whether you're walking and when you're running. Walking, running, walking, running. That's like temperature. So temperature, when something's hotter, that means atoms and molecules move around much more quickly. So reactions, ow. I banged my knee on the cabinet. Oh, jeez. So reactions occur much more quickly in higher temperatures than in cooler temperatures. Just like if you are running for those 50 Easter eggs, it's much faster. The time is quicker as opposed to you walking for the Easter eggs. That's temperature. Third one surface area. So how spread out something is. Let's say we are back to you and your 4 siblings. Now, when you're kids, a lot of times younger kids follow the leader. They follow the older sibling. Oh, the older sibling goes in this room, all the younger ones go to that room too, because that's the cool thing to do, whatever. So let's say all 5 of you are looking for the Easter eggs, and you all go to the same spots at the same time. It might still be slow, but compare that time to if all 5 of you spread out and searched for the eggs on your own. You would come up with the 50 much more quickly if you spread out, if your surface area increased, as opposed to if all 5 of you just stayed in the same spot and looked in the same spots at the same time. That's not using the people very well. It's like baseball or softball. If all 9 fielders were at the same spot at the same time, that's stupid. Doesn't make any sense. That's why in baseball all the fielders spread out, because you cover more area, more surface area, and so the outs are much more, it's quicker to get the outs. So in general, surface area affects the rate. A higher area that's spread out, the faster the reaction. I compare that to a sugar cube versus powdered sugar in coffee or tea, right? The powdered sugar dissolves much more quickly than the cube. Lastly, a catalyst. A catalyst in a reaction is kind of like a cheat code. A catalyst makes a reaction occur much more quickly. It happens almost instantaneously. So the Easter egg hunt, imagine that a cousin or an uncle or an aunt tells you where they are. Now you don't have to go hunting in gutters or like rose bushes or thorn bushes or tall grass. You know where the eggs are. It's like, one's in this, behind this garbage can. Oh, one's in the downspout. So you know where they are, so you immediately go and find them. So a catalyst is like a cheat code. It's like someone telling you where things are, and that speeds up a reaction as well. All right. So those are the 4 things that can affect the speed of a reaction, how quickly or slowly a reaction takes place. We're going to be dealing with that for the next few lessons. So great. Thanks for listening, everybody. Make sure to read that article about sugar and explosion.